Kia ora and welcome back to ECG Boot Camp, an introduction to ECG interpretation by a med student for med students. And this is video number 4, Rhythm 1. So far we've talked about our system for interpreting ECG, RRAPWQST, RRAPWQST, RRAPWQST. We're really going to get that into our heads. And we've also talked about the first R, which was rate, and we've talked about 2 methods of determining the rate, or 3 methods. One of them, read it off the interpretation at the top. But in an exam, you can either take the number 300 and divide it by the number of large squares between R waves, or you can count the number of QRS complexes and multiply it by 6. So that's the whole rhythm strip, the whole 10 seconds, times 6. And that's particularly useful when the rate is irregular, when the rhythm is irregular. So that gets us on to rhythm. And I'm actually going to split this. I initially tried to record a video covering everything in rhythm, and that turned into a 40-minute video, and none of us wants that. So I'm going to make a start on part of rhythm now, and I'll do some small videos covering other bits of it next. So what is rhythm? Well, what we're talking about when we talk about rhythm is we're talking about whereabouts is the heartbeat coming from. We know that the heart has an electrical conducting system with pacemaker cells in the SA node, which get the signals that those cells make get conducted to the AV node. There's a delay, and then they get conducted down the AV bundles, or the bundle of His, which has left and right bundle branches, to Purkinje fibres, and into the ventricles. And so this all causes the atria to contract together, and then the ventricles to contract together. So in a normal situation, the electrical activity of the heart comes from the sinus node. When we're trying to figure out rhythm, we're trying to figure out if the heartbeat is being generated by the sinus node or if it's actually coming from somewhere else. And the reason that this can happen is that the heart's quite an important part of the body, and our bodies are reasonably clever and don't want to lose a beating heart given how important it is. And so there's backup pacemaker cells in other parts of the heart, in the AV node and in the ventricles themselves. And those cells can take over if the sinus node stops beating, or if signals aren't getting from A to B. So there's a few ways that we can figure out what's going on with the rhythm, and I'm going to teach you a system for doing that. And it's basically pattern recognition at the end of the day, but we're going to learn a few questions you can ask to help you systematically assess what's going on with the rhythm. So in this video, I'll go over the system, and then in coming videos, I'll go over some specific rhythms that you need to learn, and that's going to be some rote learning. So the system, things we need to think about. One of them we already know how to do. Is it fast or slow? So is it a tachycardia over 100? Is it a bradycardia less than 60? Or is it a normal rate? So we know how to assess the rate already. Number 2, is it regular or irregular? So we're talking about QRS complexes here. Is the distance between QRS complexes the same every time, or does it vary? You can do that by eyeballing it, but I think the best way to do it, and the way that you should do it when you're demonstrating it to your seniors, is going to be that you just use the bottom of this. You've probably seen some people do this. So you line up a piece of paper with your QRS complexes, draw a few wee lines, and then you can slide it across and see if they keep on lining up, and if they do, then it's nice and regular. Hopefully that showed up okay. If a rhythm is irregular, then we need to know, is it regularly or irregularly? Irregular. So number 3, wide or narrow. So that's talking about our QRS complexes. And a wide QRS is greater than 3 small squares, 120 milliseconds, for the purposes of this. And the reason we care about that is that if the QRS complex is wide, there's 2 reasons really that can have happened. One reason is that the QRS complex has been generated by the ventricles, so it's a ventricular complex rather than a sinus or supraventricular one. And then the other reason is that it still comes from further up in the conducting system, so it might be a sinus beat or a junctional beat or whatever. We'll talk about what that means in a subsequent video. But that there's been some kind of conduction delay. All right, so the next thing, are there P waves? So we know that P waves are our ECG representation of the atria depolarizing. And so if the SA node is discharging its electrical signals and thus spreading through the atria and causing them to depolarize and contract, we get P waves. If it's not, if the SA node's not doing that, you don't get P waves. So are there P waves? And then finally, what's the relationship of the P waves to the QRS complex? So is there a P wave for every QRS complex? And that's getting into things like heart block. And we'll have a little bit of a talk about that in a later video as well. So that's the basic system and the basic questions that we can ask ourselves when we're trying to figure out a rhythm. So just recapping, a rhythm really means whereabouts is the electrical signal in the heart coming from. Questions we can ask to help figure that out. Is it fast or slow? Is it regular or irregular? And if it's irregular, is it regularly so? Is it wide or narrow, the QRS complex, meaning greater than 3 small squares makes it wide? Do we have P waves? And what's the relationship of P waves to the QRS complexes? So that's our system for assessing the rhythm. And in the next video, we're going to have a talk about some patterns that you need to recognize when it comes to some fast rhythms. So I'll see you then. Cheers.